All right, today we're going to take a look at a couple of examples of finding zeros using the polar shortcut. And we're going to be finding we're going to start. I'm going to go through maybe 4 or 5 examples, and every time I do the example, we're going to give you a new different shortcut that we can use, so that hopefully by the time we get to the end, you'll have multiple shortcuts that can really make these problems nice and shorter than they are doing it the long way. We'll probably start the first one doing it the long way. All right, so I got x cubed equals 8. So we're going to start by converting this to polar. And we're going to convert it to polar in 3 different ways. So x equals 8 squared plus 0 squared. Oops, r equals. And theta equals tan inverse 0 over 8. So this is 8, and this is 0 degrees. So x cubed equals 8, 0 degrees. Now I said that you could do this in 3 different ways. So 8, 0 is the same as 8, 360, which is the same as 8, 720. And obviously we could keep going, but we know that if we keep going, we just start repeating our solution. So these are going to give us 3 unique answers. Step number 2, apply de Moivre's theorem. Okay, so this is 8 to the 1/3, 1/3 times 0. This becomes 8 to the 1/3, 360. 1/3 times 360. This is 8 to the 1/3, 1/3 times 720. This becomes 2, 0. This becomes 2, 120. This becomes 2, 240. Okay, now I need to convert these back to polar. Excuse me, come back to standard, x plus yi. We have our 3 solutions already in polar right here. Here's our 3 solutions. So I want to convert these into standard. Of course, x equals 2 cosine 0, y equals 2 sine 0. So this gives me 2 plus 0i. And here I have x equals 2 cosine 120 and y equals 2 sine 120. So x equals, negative 1 plus the square root of 3i. This is 1.73, if you're not familiar with that. And on this one, x equals 2 cosine 240 and y equals 2 sine 240. And I get negative 1 minus 1.73i, which if we have our decimals memorized, is that. All right, so that's a full blown out, those are the steps that we do. And I'm going to write them down. Step 1, convert to polar in n different ways. And by n, I mean whatever this degree is. This is my n. Okay, and this is where we did step 1. Step 2, apply de Moivre's theorem. Okay, de Moivre's theorem lets us move this 1/3 into the problem by making it 8 to the 1/3 and 1/3 times 0. Okay, so here we did that 3 times. And here we did it again 3 times. We applied de Moivre's theorem. Step 3, convert back to standard. Okay, so here we are. We converted back to standard using our equations, and we got these answers. Okay. All right, now let's take a look at our second problem, and this time we're going to see if we can find some shortcuts here to help us out. 32 plus 0i. Step 1, convert to polar in 5 different ways. Okay? R is the square root of 32 squared plus 0 squared. Theta is tan inverse 0 over 32. So we have 32 0 degrees. This is x to the 5th. And I have 32 360, 32 720, 32 1080, 32 1440. All right. Next, we are going to apply de Moivre's theorem. So we are looking at the 1/5 power. So this is 32 to the 1/5, and I have 1/5 times 0. Okay? This gives me 2 comma 0. All right, now I'm going to show you the first shortcut. We know this starts repeating after 360 degrees. Okay? On the last problem, we went from 0 to 120 to 240. Each one of these is evenly spaced. The next one would be 360. Basically, if I take 360 degrees and divide it into 3 parts, I get 120, 240, 0. We're going to apply that here. I'm going to take 360 and divide it into 5 parts. So I go 360 over 5, and that gives me 72 degrees. So here's our first shortcut. We're going to fill in this column by simply taking all the multiples of 72 degrees. There's 5 of them. Of course, if I go one more, I get to 360, which repeats back up to here. So I'm going to stop after I get 5 of them. Okay, I don't have to apply de Moivre's every time. I can go to this shortcut. Now we're going to x equals 2 cosine 0, y equals 2 sine 0, x equals 2 cosine 72, x equals 2 sine 72, sorry, y equals, x equals 2 cosine 144, y equals 2 sine 144, x equals 2 cosine 216, y equals 2 sine 216, and x equals 2 cosine 288, and y equals 2 sine 288. Okay? All right, let's see if I get my calculator out here. Clear. 2 cos 72.618. This one I know. 2 plus 0i. This one's 0.618 plus. Second enter. Sign. 1.9. 1.9i, roughly. All right. And I would continue down and finish these just so you can check. Actually, I'll do one more. 2 cos 144 negative 1.62 plus second enter sine is 1.18. All right, and then using a shortcut that you don't have yet, we'll talk about next is going to be 0.618 minus 1.9i. I think that should do it. I think those will be conjugates. You're going to get conjugate pairs, and we're going to talk about that in our third shortcut. All right. Let's try another one, see if we can make this a little smoother, see where we're getting here. So first I'm going to convert the polar. 0 squared plus 16 squared, square root 16, and theta is tan inverse. Now remember, this is 0 plus 16i, so in this case it's 16 over 0, which is 90 degrees. This is undefined. The angle whose tangent is undefined is 90 degrees. So we're going to go 1690. Okay, and I'm taking that to the 1/4 power. So this is 22.5 degrees. Okay, and since it's dividing this into 4, it's 90 degrees. All these are separated by 90 degrees. And interestingly enough, if I were to add 90 again, I would get 382.5, which we see is the same as 22.5. So we did stop at the right spot. All right, so we've got that shortcut pretty good. We don't have to write anything down here. We can go right over and come down this column. Now we're going to show you a little interesting picture. This is 22.5 degrees. That's about here. Okay. I've got another one at 112. I've got another one here at 202. And I've got another one here at 292. Okay, this is what these would look like if I graph them on a polar graph. Let me make it bigger. All right. Well, here's my shortcut for you. When I do my first point, remember the last step here is unconvert these. I'm going to go up here. I'm going to just do the first one. X equals 2 cosine 22.5. Y equals 2 sine 22.5. 2 cosine 22.5. 2 sine 22.5. So I've got 1.85 plus 0.77i. Let's do it this way. 1.85 plus 0.77i. If I look at my picture, bring this down, and I look at my picture, with a little bit of thought, I know that these are 90 degrees apart, and this creates a perfect square. I guess that's redundant, perfect square, but this is over 1.85 and up 0.77. This is very symmetric. If I think about it for a minute, this is going to be back 0.77 plus up 1.85i. This one came back 1.85 and went down the 0.77. And this one came over 0.77 and went down to the 1.85i. So by just doing my first point, it's possible to fill in the rest of these very quickly and easily by drawing a picture and understanding that this is going to be a square evenly separated by 90 degrees. I'll go back now and I'll show you the shortcut I used here because it was a similar shortcut. Okay. If I have a circle, we were at 20, 272, 2144, 2216, and 2288. And I had done this 618 plus 1.9i, and I had done this one as negative 1.62 plus 1.18i. And then I used the symmetry of this pentagon. Remember, these are all evenly spaced. These are up and down. This is back 1.62 and down 1.18, which is what I had put here. And this one is over the 0.618 but down the 1.9i. Okay. Interesting to note, these of course are conjugates of each other. The x values are the same, but we are merely above the axis or below the axis. So the only thing that changed here was the middle sign. Same thing here. Since these are above each other, okay, I have 1.62, negative 1.62. The x's are the same. The y's changed. This one, there are no conjugates. There are no points that are directly above and below each other. And if I look at this pattern, there are no conjugates in the pattern. Okay? There are still some things going on. When I go directly across the circle, that's a positive and negative. This is positive 1.85 plus 0.77i, and this is a negative 1.85 plus 0.77i. So really, these are opposites of each other. Opposite the circle, they are opposite positive and negative. Same thing with these two. We have a negative 0.77 plus 1.85, and here we have a positive 0.77 minus 1.85. So those are opposite. All right, so we're getting to a point now where we can start using the picture along with our skills to really start coming up with solutions quickly. All right, x to the 6 equals negative 729. So this is negative 729 plus 0i. We're going to convert this. Negative 729 squared plus 0 squared is 729. Careful. And theta is tan inverse. I have negative 729 over 0. Now be careful on this one. This is kind of weird. This is undefined. That makes it 90. But since the x value is negative, we have to add 180, and this becomes 270 degrees. Okay, 270 degrees. So x to the 6 is 729, 270. Okay. All right, we're ready to apply de Moivre's. 1/6, that's 3, I think. 2, 4, yeah, 3. And then 1/6 the 270. 6, 135 over, brain fart, over 345? No. Could it be 45 degrees? 90, 90, yeah, there you go. All right, sorry about that. A little slow there. All right, 345, okay? And from here, I take 360 and divide by 6. So that tells me all of these are 60 degrees apart, okay? So I'm going to go right to my picture. Okay, 345. Now I'm going to go 60 degrees, so that puts me at 3,105, 3,165, 3,225, 3,285, and 345. All right, here is a perfect hexagon. Okay, badly drawn. Let's see what I have here. This is going to be, let's convert. X equals 3 cosine 45, y equals 3 sine 45. So I get out my calculator. 3 cosine 45 is 2.12, and I think I know what 3 sine 45 is going to be. Same thing. Sine and cosine of 45 are the same. So I get 2.12 plus 2.12i. Directly across from us, the opposite will be the opposite. This is negative 2.12 minus 2.12i. Now I've still got some work to do here. 3 105, 3 cos 105, oops, 3 cos 105 is negative 0.77, and 3 sine 105 is 2.89. So I got negative 78, 2.9. Negative 0.78, 2.9. Negative 0.78 plus 2.9i. And across from that is going to be 0.78 minus 2.9i. And I think this is 15 degrees from here, 15 degrees from here. Those should flip-flop. This should be negative 2.9i plus 0.78i. Negative 2.9 plus 0.78i. And this one should be 2.9 minus 0.78i. So I use the symmetry of my shape to come up with my solutions. Okay? All right, hopefully I gave you enough to think about. I'm sure I did. You are going to need to practice these. Okay, you're going to need to practice these. I had one more ready to go, but we'll see how loud this gets here. I got kids coming in the classroom. 0 plus 243i. R equals 0 squared plus 243 squared is 243. Theta is 243 over 0, tan inverse, which is undefined, so that's 90 degrees. So we are at 243, 90 degrees. Taking this to the 1/5 power is 318 degrees. Drawing a picture, 318 degrees, and they are separated by 72. So that puts me at 390, 3162, add 72 to that, 244, 244, and add 72 to that, 316, 316. All right, 318, 3, oops, put my pen down, 3 cosine 18, 2.85, 3 sine 18, 0.92, 0.93, so I get 2.9 and 0.93. So this is 2.9 plus 0.93i. This is opposite, negative 2.9 plus 0.93i. This is straight up 3. I'll let you ponder how I did that one so fast. And then let's do this. 316, 3 cosine 316, 2.2, 3 sine 316, negative 2.1. So I got 2.2 and negative 2.1. So this is 2.2 minus 2.1i, and this is negative 2.2 minus 2.1i. 1, 2, 3, 4, 5 solutions. All right, good luck. Thanks for watching.